Hello, this is Marta Yebra. Welcome to the third video of the video series on field methods in remote sensing on most common fieldwork problems. The approach to planning fieldwork in remote sensing consists in identifying pitfalls and problems and selecting appropriate solutions in advance. So in this video, I will summarize the most common fieldwork problems, and then in the next and latest video of the series, I will present some procedures for avoiding these problems in the field and for making appropriate measurements and observations. So it seems self-evident that one must have objectives before beginning a project. However, often the objectives are not thought out in sufficient detail. So a good written statement of objectives will set the agenda for the entire project and will determine which methods should be used at every stage of work. So a comprehensive statement of objectives should include some of these, all of these items. The location and site of the study area, the scale of work, the expected accuracy of the final results, the proposed end users of the final product, the type of ancillary information to be used. This is, for example, image data, photos, or other reference materials that you will use, and also the field methods to be used. We will extend this more in the next video, but each of these components of the objective statements will help to determine the methods selected for fieldwork, including sampling procedures, locational techniques, and details of methods for making observations in the field. The second big problem is inadequate sampling planning. So planning fieldwork should consider all these aspects here, listed here: the purpose of the sampling area, the variables that need to be measured, the parameters. They need to be consideration in the economic and logistic limitations as well. Also carefully consider the methods for sample collection, the equipment needed to make sure that the equipment is in good shape and working and calibrated. There should be consideration also to the sampling designs, both on the site of the sampling and the location. The map accuracy is dependent greatly on the degree to which sample data truly represent the land surface. So this involves carrying a sufficient number of samples in each land cover map that you are working in, to assure that the aggregated sample will represent all the variation within a category. If you failure achieving this, you will not be able to have a proper validation of your methodology. So to achieve that, you also need to have good protocols for collecting the information, good methods for analysis the data, and you should always estimate the costs and expected accuracy of the results. So it is also very difficult to reconcile the high resolution field work where the human eye at a distance of only a few meters can see a lot of things and abundance of ground information with the grossest resolution of the images. So fieldwork consists largely in collecting information that can be scaled up by aggregation to correspond to information of the image. This involves, in some cases, consider the need to scale the field information, or what we call generalized. To do this, one must visualize the extent of a ground pixel when you are on the field, which is the area of ground cover presented by an image pixel, and then it is necessary to collect and aggregate ground data to best represent that pixel of the image on the ground. The next common error is errors in location. These days, with global positioning systems, these problems are greatly reduced. However, it is difficult to be certain that a field location is accurately tied to a single specific image pixel coordinate. For this reason, it is necessary to estimate a potential locational error in pixel units and adjust the ground sample unit size accordingly. The potential for having a damaging location error is highest on surfaces that have a high frequency of variation in cover type. This is, on the other hand, large homogeneous areas allow some locational errors without damaging effects as long as the location is not near a categorical boundary. So another common error is an inappropriate observation and measurements. So the question of what to measure, how to measure it, and to what level of detail should be measured is still one of the greatest questions for field work. The level of detail collected may be insufficient to meet the overall objectives in terms of number of categories to be mapped if we are dealing with map classification, or the level of accuracy target for a specific variable. The opposite sometimes may occur when more data is collected than really needed. And this is a common mistake in field work, and it happens because there is an insufficient thought given to the project objectives, and you can waste days of valuable field time. However, some researchers prefer to error on the other side and over collecting data. They collect everything possible because they are uncertain again about which biophysical variables they want to target. This is also an inefficient way to do the field work because you may spend more time doing field work collecting data that you will never use. The next problems arise when you have inadequate reference materials. This is, for example, photos or field work that has been done in different time of the year or by more than a few years different between the data, the imagery collection. Project planners can overcome this difficulty by planning field work to coincide with the overflights of the satellites of the aircraft, and this should be done always. This looks trivial, but there are cases when I have read a few papers where the field work has been done 2 years after the data collection, the imagery collection. And of course, as you can imagine, in those 2 years, you cannot assume that the vegetation is going to be exactly the same. So this slide finally summarizes all the problems we have discussed, and with this I finish this short video, and you are welcome to click in the next video where I will give you some clues to make a good planning to avoid all these problems.